Hello, and welcome to this presentation on basic trigonometry. This is part 2 in the basic trigonometry series. Within the previous presentation, we reviewed the basic trig functions of sine, cos, and tan, and we applied these trigonometric ratios to the solution of some basic problems. This part 2 of the series purely looks at applications and solution of practical problems. This presentation does assume you've seen the part 1 of the basic trigonometry introduction. Just a very brief recap from part 1 of the presentation. We'll be using within this presentation Pythagoras' theorem, as shown here in the bolded box. The hypotenuse squared is equal to the sum of the other two sides squared, a squared and b squared in the above diagram. And also a recap of the basic trig ratios we looked at in the previous presentation. We refer sometimes to this mnemonic SO, Ka, TOA. For the SOC part of the mnemonic, stands for the sine of an angle, angle theta, is equal to the opposite side of a right angled triangle divided by the hypotenuse side. The cosine of angle theta is the adjacent side over the hypotenuse, and the tangent of angle theta is the opposite over the adjacent side of the triangle. If you want to recap those basic trig ratios and how to use them, I would encourage you to revisit part 1 of the basic trig ratio series. Also, angular units of measure were outlined in the previous presentation. We can specify angles in terms of decimal notation, decimal degrees, or also sexagesimal notation, that's in terms of degrees, minutes, and seconds. Just to recap, there are 360 degrees in a circle, 360 degrees in our circle, or in one revolution. 60 minutes in 1 degree, and there are 60 seconds in 1 minute, a second being a very small unit of angular measure. Again, if you want recap on angular units of measure, I suggest you revisit the presentation related to an introduction to trigonometry. Here are some questions from Worksheet 3 of our notes. They all relate to the solution of right-angled triangles. I would encourage you to stop the presentation and attempt questions 1b through to 5b, stated on this slide. The answers are shown in the brackets on the right-hand side. I encourage you to read the questions very carefully, extract the information from the questions, draw appropriate diagrams or sketches, find the right-angled triangles to be solved, label the triangle, find the appropriate ratios, etc., and so solve the problem. I will show the full solutions to these questions on the following slides. Question 1b. A gate 2.5 meters in length and 1.5 meters in height is to be strengthened by welding a diagonal bar across its frame. We have to calculate the length of the bar and the angle that the bar makes with the bottom rail of the gate. So here's my sketch on the left hand side of the gate, which has a width of 2.5 meters, I'm using decimals here, and 1.5 meters in the height. We're asked to find the length of the diagonal bar, I've labelled that as x, and also the angle theta between the bottom rail and the diagonal bar. So firstly, let's calculate the length of the diagonal bar. So to do this, I'm going to use Pythagoras' theorem. Pythagoras' theorem states that the square of the hypotenuse, that's labelled x in this case, so x squared, is equal to the sum of the squares of the other two sides. So in this case, the other two sides are 2.5 squared added to 1.5 squared. So therefore, x is equal to the square root of 8.5, which is equal to 2.915 meters. Now part 2, we're going to find the angle theta. So labelling the sides of our right angled triangle here, this would be the opposite side. This is obviously the hypotenuse, the largest side, and this would be the adjacent side. Because I have all three sides of the right angled triangle here, I can use any of the trig functions, the sine, cos, or the tan. However, in the original question I was given the opposite side and the adjacent side, so that relates to the tan function. So I'm going to use the tan function because that was the information originally given. So tan of the angle, in this case we've called it theta, is equal to the opposite side, 1.5 meters, divided by the adjacent side, 2.5 meters. So angle theta is equal to the inverse tan, so that can be written as tan to the -1, or arc tan of 0.6. That's the 1.5 divided by 2.5. So therefore angle theta is equal to 30.96 degrees. On the sheet that's stated in degrees, minutes and seconds, so pressing the DMS button, that equals to 30 degrees and 58 minutes. Question 2b. A road has a steady incline of 10.25 degrees over 200 meters horizontal distance. We've got to find how high is the climb over this distance. So from the sketch, it's my road on the incline of 10.25 degrees and the horizontal distance travelled is 200 meters. What's the height of the incline over those 200 meters? So as we're given one angle and one side of a right angled triangle, then we're going to use trig to help us find the answer here. So to help me solve this problem, the first thing I need to do is to label the sides of my right angled triangle shown in the sketch. So given the angle of 10.25 degrees shown here, the opposite side of my triangle would be h in this case. The hypotenuse is always the longest side, so that's this side of my triangle. And so that leaves me with the 200 meters as the adjacent side. Now some of you will instantly see which trig function to use in this case, but as we outlined in the previous presentation, if you're unsure, then you can apply the mnemonic SOHCAHTOA and then from that hopefully decide which function to use. So I just put down my SOHCAHTOA mnemonic for a moment and just tick off information I know. What do I know in this case? Well, I know the angle, 10.25 degrees, so I can find the sine of the angle, the cos of the angle, the tan of the angle. It's on my calculator. What else do I know in this particular question? I know the adjacent side. So I've got the A and I've got the A. What am I trying to find this time? I'm trying to find the opposite side of the triangle. So the O's in my mnemonic. I can clearly see I have all the information I need to use the tangent function. So to find height h, I have tan of the angle, and the angle in this case is 10.25 degrees. And that's equal to the opposite side, which in this case is labelled as h, divided by the adjacent side, which we're given as 200. I need to rearrange the equation to make h a subject, so I need to multiply both sides by 200. So 200 multiplied by the tan of 10.25 degrees is equal to h. All we do is turn the equation around, so therefore height h is equal to 200 multiplied by, and the tan of 10.25 on my calculator, 0.1808. That's the value for tan of 10.25 from my calculator. Therefore the height is equal to 36.2 meters. That's to one decimal place. Question 3b. Each step of a set of stairs has a rise of 190 millimeters and a tread of 250 millimeters. What angle does the handrail make with the horizontal? So just be careful with the terminology used here. When it mentions rise, that's this height here of a step. When it mentions tread, that's this width here of the step. A bit of terminology there for us. So idealizing that into my right angled triangle, that's shown here with the horizontal dimension of 250 millimeters and the height of 190 millimeters. We're asked to find this angle theta of the triangle. So again, labeling the sides of the right angled triangle here, this would be the opposite side because it's opposite the angle we're trying to find. So I've got my opposite side here. The handrail would be the hypotenuse of my triangle. That's the longest side, always opposite the right angle. And so that leaves me with the 250mm as the adjacent side. So I think it's fairly clear to see here, given the opposite side and the adjacent side of the triangle, that means we need to use the tan function to find the angle theta for the handrail. So to find angle theta, we're using the tan function. From tan theta is equal to the opposite side, 190mm, divided by the adjacent side, 250mm. We can evaluate the angle theta. Therefore, angle theta is equal to tan to the -1, the inverse tangent, of 19 divided by 25. I just cancelled top and bottom of the fraction by 10. That gives us an angle of 37.23 degrees. And pressing the DMS button on the calculator, that's equivalent to 37 degrees and 13 minutes. Question 4b, a slightly more complicated question in the way it's described. A point 100 meters from the center of a factory chimney supports a theodolite of height 1.5 meters. A theodolite is a device used when surveying various landscapes. If the theodolite gives an angle of 14.8 degrees to the top of the chimney from this position, we've got to find the height of the chimney. So in the sketch below, I've tried to highlight the information given to us. So we're told that the location of the theodolite is 100 meters from the center of the factory chimney. And I'm showing that dimension here, from the center of the factory chimney to the theodolite, shown here. And we're also given in the question that the theodolite states an angle of 14.8 degrees to the top of the chimney from that position. So angle of 14.8 degrees here. So you can see now I've formed a right angled triangle, which I can now solve to find the value of x, which is this height shown here in the red arrow. But don't forget, I'm asked to find the actual height of the chimney, h, so I'll need to add 1.5 to x to find h. So as always with these problems, the first thing to do is to label the size of my right angled triangle. This is the angle given, 14.8 degrees, so the opposite side of the triangle will be that labelled x here. The hypotenuse of the triangle is always the longest side, always opposite the right angle, so this is the hypotenuse side. That leaves us with the 100 meters being the adjacent side of the triangle. So again, if you're unsure which of the trig ratios to use, you can always state your SOHCAHTOA mnemonic and simply tick off information we know. What do we know? We know the angle, so I can find the sine of the angle, the cos of the angle, or the tan of the angle. What else do I know? I know the adjacent side, so I've got the A and the A. What am I trying to find in this case? I'm trying to find the opposite side labelled x. So the opposite side occurs here, and the opposite side occurs here. I've got most information for the tangent function, so that's the one I'll be using. So step 1, to find the dimension x, I will use my tangent function. So tan of the angle, and the angle in this case is 14.8 degrees, is equal to the opposite side, we've labelled that as x, divided by the adjacent side, and the adjacent side we're given a value of 100 meters. Rearranging the equation, x is equal to 100 multiplied by tan, 14.8 degrees. Typing that into my calculator, then dimension x is equal to 26.421 meters. That's the 3 decimal places. So therefore, step 2, find height h. H is simply equal to the 26.421, add the 1.5 meters for the tripod. We get 27.921 meters. Question 5b. A pair of dividers 120 millimeters long is open to measure 40 millimeters. We've got to calculate the angle between the two legs. So the image here on the left hand side of the slide shows a pair of dividers. The leg length is 120 millimeters, shown here, and they're opened up to measure 40 millimeters. So that's the 40 millimeters here. The question wants us to find the angle between the legs. That would be this angle shown here. I would encourage you to stop the presentation and attempt this question, but I'll work through the full solution in just one moment. So here's a solution to question 5b. What we're essentially given in the question is an isosceles triangle where we know two sides, the 120 millimeter leg lengths. By drawing a vertical through the dividers, we can actually form a right angled triangle shown here in the sketch, and which is shown here for clarity on the right hand side. So this is the right angled triangle we're going to solve. We'll find the value of angle x, and then we will simply double it to find the value of angle theta. So again, as always, we need to label our triangle. So right angled triangle here, we're trying to find angle x. This would be the opposite side here. The hypotenuse, always the longest side, always opposite the right angle. So that leaves us with the adjacent side here. So again, if you're not sure which of the sine, cos or tan ratio to use, you can write the SOHCAHTOA mnemonic down and use that. But I think it's reasonably straightforward here, given the opposite side and the hypotenuse side, and asked to find the angle, it would actually be the sine ratio. So step one, I'm going to find angle x. So from the sine ratio, sine of angle x is equal to the opposite side, in this case that's a value of 20, divided by the hypotenuse, that's 120. Find angle x, that's equal to the arc sine of 1 divided by 6. That's the ratio 20 upon 12. So therefore angle x is equal to 9.594 degrees. But we want to find angle theta, and angle theta is twice angle x. So it's 2 multiplied by the 9.594, which is equal to 19.188 degrees. Or theta is equal to 19 degrees, 11 minutes and 17 seconds. So here's worksheet 3 relating to right angled triangle problems. Question 6b to question 9b. I would strongly encourage you to stop the presentation and attempt these questions. Read each of the questions very carefully and extract the information from the question, draw appropriate sketches where required, try and find the right angled triangles within the sketch, label the sides of the triangle, choose the appropriate functions, etc. Lay your solutions out very clearly, very precisely. The answers to each of the questions are shown on the right hand side here. On the following slides, I will overview each of the solutions, but I will not actually work through them in great detail, but I will try and show you what sketch you should have drawn, how you should have found your right angled triangle, and hopefully from there you can then solve the triangle. But I would strongly encourage you to have an attempt of these questions on your own before referring to the following slides. So question 6b, a 10-meter ladder, shown here, L is 10 meters, just reaches the gutter, which is 8 meters above the ground. Here's the gutter, and it's a height h 8 meters above the ground. We're asked to find what angle that the ladder makes with the ground and how far the foot of the ladder is from the house. So this slide shows the sketch. If you think you can now solve the problem from here, I'd encourage you to stop the presentation and attempt this question. But further information is shown on the following slide. This slide shows the right angle triangle you should have formed from the sketch, where we need to find angle theta, the angle of the ladder to the ground, and also dimension x, the distance the foot of the ladder is from the house. I would encourage you to label the size of the triangle and then use the appropriate trig ratio to find the angle, and then you can use Pythagoras theorem to find the dimension x. But I will let you complete the solution. Question 7b. A 700mm diameter bicycle wheel has a chalk mark on the tyre. The chalk mark is shown down here in yellow. If the mark is touching the road before moving the wheel 40 degrees, how high will the chalk mark rise above the road? So this shows the sketch of the problem. And again, if you think you can solve for the dimension h from here, I would encourage you to stop the presentation and attempt this question now. But slightly more information is given on the following slide. Here is the right angled triangle you should have formed from the information given and the sketch on the left hand side. Notice that the radius of course is half the diameter given in the question. I'd encourage you to stop the presentation and see if you can now solve for dimension h given the information on this slide. Question 8. A symmetrical roof as shown in the diagram. We've got to find the total height of the roof, in other words from the peak here to the ground here. There's a hint in the question below to form the two right angled triangles. Again, I would encourage you to stop the presentation and see if you can solve the problem from the information given. If not, further information is given on the following slide. Here are the two triangles we should have formed from the information in the question. This first triangle here I'm highlighted in yellow would be this triangle here. And the second triangle I'm highlighting here would be this triangle here. Basically you need to work out the value of x in the first triangle, y from the second triangle, and add them together to get the total height of the roof. Finally, just notice for reference where this dimension of 4 meters is derived from. It's from here, the 32 meters minus the 24 meters, all divided by 2, produces the 4 meters for the triangle side lengths. I suggest you to think that through carefully from the geometry given in the original question. Again, I will leave you to try and complete this question. And finally, question 9. The altitude of the sun was known to be 34 degrees and 13 minutes. The length of the shadow of the chimney was 55 meters. We've got to find the height of the chimney from that information. The sketch below shows you the triangle you should form given the information, and hopefully from there you'll be able to solve for height h. Again, I will leave you to undertake the calculations. For reference, here's the bibliography used to help generate the presentation. I hope this presentation has been of interest to you, and thank you for viewing.